Hey guys, my name is Ethan, this is Carberra, and welcome to the series where I teach you how to analyze and visualize data in Python. Today we are talking about notebooks, so I'm going to be showing you how to create one, how to add new cells, how cells work, what cells even are, and I'm also going to be telling you about the uses for notebooks and why so many people in the data science and machine learning industries actually use them on a day-to-day basis. Of course, if you find the video helpful at any point, then consider liking to let me know and subscribing so you don't miss out on new videos in the series. But yeah, with that out of the way, let's get into it. As I said in the introduction video, there are a few different ways that you can do notebooks, and it really kind of depends on what IDE you're using. As I said, VS Code has inbuilt Jupyter support. I know Visual Studio on its own does not. You can always use the online one if you wish to as well. However, we are going to be doing this entirely off the VS Code one, so if any steps are different, then I'm sorry. But the actual usage of a notebook should be the same, regardless of which IDE or environment you're using. So we're going to go in here and we're going to create a new file, and we're going to call this, well, I'm going to call this by the episode number. So I'm going to do 2, and then using notebooks, you can call it whatever you want. And we're going to do .ipynb. It's very important. It's not a .py file, it's a .ipynb file. Now that stands for IPython notebooks. So the first thing to note about notebooks, yes, I want to do all that stuff, is that they do not use the standard CPython. You install CPython as you would normally. However, IPython works a little bit differently, and I'm not entirely sure. I don't know what the I stands for. I believe it's interactive, but correct me if I'm wrong. But essentially, it is a version of Python that allows for certain parts of the program to be suspended, if that makes sense. And it will make more sense when I actually show you kind of how stuff is working. So I guess I'll just get straight into it and hope that it makes sense later down the line if you're not understanding it so far. So the first thing to do is to put in this line here, matplotlib in line. And this first line just tells the notebook that we want our matplotlib graphs to be drawn, quote unquote, in line. I believe this has different effects for different environments, but inline is definitely the one you want for VS Code. Otherwise, it just won't work at all. You can omit this line, and it will also work fine. But as far as I can tell, this is a bit of a standard, so I'm including it just in case anyone shouts at me for not implementing it. Typically, in this first cell as well, I'll talk about cells in a wee second, we would do any imports that we want to do. So for this, I'm just going to do import math, and I'm going to keep it real simple for this, just so we actually understand. So this is what's called a cell. So as you can see, there's this little box here, and this cell is sort of like a Python program in itself in a weird way. So if I hit Control Enter, it'll run that, and that does work on the online version as well. And as you can see, this changes to 1, so that means this has run. It was the first cell to run, and now this is stored in memory. So we can create another cell, and then we can do print math.square root 9. If we hit that, it will do 3. So when we run that, we are not also running this. As you can see, this still has 1, and this now has 2. So this was stored first, and this was stored second. If I were to run this against like 16, for example, this would turn to 3. So as you can see, this ran again. Its new state has been stored. However, the 1 up here hasn't. And I can probably show you that with some variables. So the square root of 16 equals math square root of 16. And then also with a notebook, you can do, if you just have it like this, it's an unmatched thing. That's my bad. It will print it anyway. So you don't actually need a print statement. However, it will only do that if it's the last line of the cell. So for example, if I had something like I plus 1 here, it wouldn't actually print that at all. It would error instead, or I equals 1. So it wouldn't print it at all because it wasn't the last line. But because this is the last line of this, it actually prints out to the thing. So that's another thing about cells to keep in mind. But if I were to do this now, I could print square root of 16. It would come out as 4. However, if I change this again, you can see it's now 4.47. If I run this again, it's also now 4.47. So as you can see, the state of the program is being stored sort of in sections. So if I were to do, say, I don't know, let's just import NumPy. NumPy would have been installed alongside pandas, so you would have this. And if I were to try and do, say, array equals NumPy dot zeros, and we're going to say like 5, we'll get an error saying that NumPy is not defined because we've run this as 12. However, this one is still number 1, so we haven't run this again. So NumPy isn't installed at the moment or imported. So if we were to hit Control Enter and run this again, we'll see this is now 13. If we run this now, it'll actually work, and if we go to R, it'll tell us what our array is. So any previous cells need to be run if changes need to be made to them. And you can run all the cells at once by hitting this button up here. As you can see, it just runs it in a chain. You can also go here and run any previous cells, and you can go here and run any later cells. So you can choose which cells you actually want to run. This is another insert cell button actually. So does that? Oh, okay, that inserts it below the current one. I didn't actually know that. There's this one here which clears all the output. So if you clear that, it will clear the output. However, it will actually unload the cell as well. So if you do this now, oh no, never mind. It doesn't actually unload the cell. It just tells you that it does at the side. Okay, that's interesting. I do kind of wish there was a way of hiding the output for a specific cell, but that's not a thing apparently, at least in this. So there's this button here that shows the variables active in Jupyter, so we can actually see all the different ones. So we have R, we have our I, which is still around even though we deleted it, and we have the square root of 16. We have this save notebook that we can just do using Control S, and an export as HTML or PDF. We're going to export it as a Python script. Oh, export fail. Never mind, apparently you can't do that. I never played around with that before. I didn't even know it was an option. So yeah, that is pretty much how notebooks work. You can see the advantages of it when it comes to development. So say if you were to load in a particularly large file and, converting it into a Python, a pandas data frame takes like 30 seconds. Every time you make a minor change to something, you don't necessarily want to load that up every single time. You want that to be stored in memory, and you can edit the bit of code you want. Just run that cell and any cells after it, and the previous state is still maintained, so you don't have to wait the 30 seconds for it to load, but you can then perform the operations on that data automatically. So it's a huge time save when you're doing stuff with enormous data and enormous operations and all that stuff, especially when it comes to AI, where you're doing, say, predictions after training a model. So you could just train the model and you can store the state in the thing, and you don't have to load it every single time, because loading a TensorFlow model honestly takes forever. So that is why data analysis and machine learning and stuff like that is done in notebooks typically, and it's also why Python is really popular for this sort of thing. One, just because of ease of development. Python is easy compared to a lot of other languages, but also because of notebooks, because you save so much time in development that any time saved in the additional speed of compiled languages just doesn't even come close. You're still losing time overall using those languages, except in very extreme situations, or in situations where sometimes the notebooks can just be a bit weird and you do have to reload the data anyway. But yeah, that is a basic breakdown of a very basic breakdown of how notebooks work, how to use them, why you might use them, and in what situations you would potentially use them. This video wasn't initially going to be that in-depth, but whatever, it's fine. We like to teach people on this channel, so it's okay. But yeah, if you do have any questions about this, then feel free to leave them in the comments below, or you can join the Discord server using the link in the description. But yeah, with that, I would like to thank my amazing patrons for being as epic and awesome as they are, and I will see you next time, where we actually start loading and saving data using pandas. So there's this whole block of doing stuff with pandas coming up, so we're going to be starting that in the next video.